the fuck is going on here, man? What the actual fuck is going on here, man? Okay, guys. It's a new day, man. It's a different day, dude. What we're gonna do is we're going to do what we always do. We're gonna pick up where we left off. How about that? Who could have imagined? Who could have guessed that we would do that? Why the fuck won't this exit out? No, I don't want this. Anytime a software, anytime you try to force me to use your software, I'm gonna not want to use it. It's basically like this, okay? If you show me an ad for something, that increases the likelihood that I'm never gonna use your product. If you show me an ad for American Eagle, the chances of me buying American Eagle, the graph starts to go down, okay? My likelihood to buy the product. If you don't show me any ads ever, chances are I might just buy your product. But as soon as you show me ads, I don't want to buy your product anymore. It's just the way it is. I'm not trying to punish you. It's a literal. It's just science, bro. It's the way it is. You know? It's the way it is. Alright, so yesterday we did an hour. We continued working on code to reconnect the client to the proper game. We mainly worked in client files. Specifically, we consulted ChatGPT for about 45 freaking minutes. We consulted ChatGPT for a very long time. We did. And apparently I'm not actually live right now, so this is you know how it is. Okay, there it is. It's a little slow sometimes, kind of like me, you know? It's the way it is, dude. There it is. Okay, baby. Let's see this. So we got going on here. Let's check our audio, dude. Winnie the Pooh going on in the background. Audio, it's there. It sounds fine. Alright, cool. Anyway, continue. So, we consulted ChatGPT about server hosting details and options to determine the best course of action. Yeah. And then we implemented code in client, which connects to the proper IP address and subsequently sends the client token to the server for client verification. Yeah, we didn't really do that much code, honestly. We stopped at line 430 in client, so let's just go over there. And let's just review what we did yesterday. Okay, so yesterday we only added this little section here, and that we did con equals nconnect in local server IP address, and then the reconnect port. So this is a tuple. It must be a tuple because we're passing the IP port combo to the connect function, and the first element in the tuple is the IP address, and in this case, oops, I think this is actually supposed to be a function call, right? Found a little buggy. No, it's not. It's not. It's now this is a basic question I done forgot. If you have a variable that references a function, when you if you have a variable that's equal to a function call, yeah, it's only equal to whatever that function returns at the time that you assign the variable. Like, actually, this is only going to get called one time. It doesn't matter how many times we reference this attribute, even though it is equal to a function, because this is a function call which returns a value, and okay, there it is, get local machine IP via dummycon. So it returns the local machine IP address, and then that means this attribute will be equal to whatever that value returns for its entire lifespan, unless you like reassign it or something. So yeah, just to clarify that. All right, so that is correct. Okay, and then we have comma reconnect port, and that is the correct port because we're going to be reconnecting directly to the sub process. We're not routing through the main process or whatever. We're just doing it through directly to the sub process. So that connection is equal to this end connect call, and that will return the network socket, which is con here. And yeah, I think that's correct. And then we have to do must add code, which sends the client token to the server to authenticate the client. And yeah, we did that. So what we added was to get the client token header. Oh, forgot to set my timer. Let's see here. We're 7 minutes in, so we're gonna go. What do we do? 68. So that's 61, right? Yeah. Is my math good? Yeah. Arithmetic on fleek here. So we get the client token header. We do that by assigning client token header to n.messageHeader function, passing in the client token object. And at this point, the client token is indeed deserialized. Okie dokie. And yeah, so it's a deserialized. And then we are basically just reserializing it again. I mean, and technically we don't have to reassign it. Should we clear the result dict after, like, since we don't need it anymore to free up memory? Yeah, and I think we should, technically. Anyway. So we'll take care of that another time. Anyway, so we get the client token header using client token header equals n.messageHeader, passing in the client token, and that will do this, which is gonna run the message header. And why do we have a function at the top and then a function at the bottom? What kind of weird shit is this? Why? Yeah, we're not using like anything. I don't even think it works like that. Anyway, I was gonna say maybe we put it below it because it has to rely on things that are above it, but I don't really think it works that way. So that's silly. Let's fix that. For whatever reason, we've decided to put our standalone function prior to the class here. Does it really matter? I don't think it does, actually. I honestly, I would say that the more proper, like, way to do this would be to have the class at the top, and then at the bottom we would have the other functions. I don't know. It's kind of 6 one way, half a dozen the other, but I just feel like this way is better, so we're just gonna leave it like that. Okay. Now, and honestly, these should probably be static functions because they are related to network. Isn't that how we do that? Static functions are functions that are like they're Python static functions. Static methods are functions defined inside a class that do not access or modify the class or instance state. They behave just like a regular function, but are grouped with the class for organizational purposes. Yeah. So we would say at static, or yeah, at static methods, and place them inside of the class indentation. Yes. But we'll do that another time. Just put the note for here. Okay, so message header is going to take in the object. It's going to get the object size using sys.getSize of. The object size string is going to be equal to a string of that object size, and then if the length of the object size string is less than 7, so we have to convert it to string to get the length of it, and then we say append number equals 7 minus the length of the object size string. So if you have 4 digits, it would be 7 minus 4, so then you would have 3 as the append num, so then you would do append string x times 3, so you would get 3 x's as a padding to pad with the amount of the missing length. The object size string would be equal to object size string plus append string. Okay, and then we said byte object size string equals object size string encode. Okay. Okay, encode is only used on strings. And pickle dumps is for serializing Python objects. Output is bytes. So they both output bytes, but encode is only for strings. Gotcha. Alright. So, yes. We have the function call passing in the client token. That's going to give us our header. Okay, so we can get rid of this now. Then we would send the client token header using con send all, sending the client token header, right? So we send that first. And then we would serialize the client token using serialized client token equal to pickle dumps the client token. So this will convert the client token into a bytes object. And then we will send the serialized client token. Or wait. Don't we need to serialize it first before we do the header? Yeah, because we're sending. Yes. Yeah, we have to serialize it first before we send the header. Right? Serialized object using pickle dumps versus original form byte size. Comparing the byte size of an object's digital form versus serialized form using pickle dumps is useful when considering what happens with pickle dumps. Compact. So if you have the original size, you get the size of. Doesn't count nested objects deeply. And then the pickle, the sample output original size is 240, pickle size 61. Right, so the sizes are different, and the pickle size is going to be smaller. Okay. So if sending using socket, should pickle object first, then create header for pickled object, then send header and then object versus creating header based on unserialized format, then serializing and sending header, then sending serialized object. Yeah, I mean, that's an obvious one right there. The best practice: serialize first, then build the header. You need to know the exact byte length of the serialized data so the receiver knows how much to read. That's a stupid question. That was a dumb question, dude. So yes, we actually found a bug here. We have to serialize it first. So then we have the serialized client token, and we're gonna pass in the serialized client token first. And then we would do consend all, sending in the header, and then we would send the serialized client token. Okay, that's taken care of. All right, so that's where we had left off. What is next to do? So next is to add server-side code in server to receive, and this is just going to be to receive the client token. We're not receiving, like, the client ID is part of the payload. It's already included. Oh, cool. We added the line number where we were working on that, so that's always good. I love when I have prepped ahead. Sometimes I don't do that. Sometimes I don't do that. Can we just receive the client token with all the data without, instead of receiving it to the client ID? Yes, that is actually true. We can do that. So let's go over to server and look at line 707 here. Let's see what we got going on. The server 707. Okay. Times have changed apparently, because this has nothing to do. Okay, here we go. I was just a little off. Alright. So if true, we don't want to read that. Okay, here we go. Reconnect system to do. Add the code which reconnects the client back to this child process using new reconnect socket. Okay. So we have reconnect system. Blah 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 blah. So if they have a connection error, we basically are going to be waiting in too much bagpipes, dog. We are going to be waiting for the client to connect. This is basically like runs, it's like a blocking operation, I believe. It's like a while loop. And it will constantly be waiting for a client to connect. And I don't know if that's actually true. Is socket.accept blocking? Yes, socket accept is blocking by default, and it does internally wait, likely with a loop or system call. It waits, blocks until a client connects to the server connect. Yeah, so it's not going to move on from that line. It's not going to, like, it's not going to pass it up, and then there's an outer while loop that reiterates, you know, and then recalls it over and over. You just have to call it like once, and it internally blocks and will wait until a client has actually like made that connection. It waits until the client connection serves out once the connection is made. It returns a new socket object for the connection to the client address. Yes. We already know this. I'm just trying to accept use like use button call select, pull, or accept. It's an OS level, and it may sit in a loop if interrupted. Select, pull, or accept. The button code just appears to freeze until the client connects it, but it's really the OS pausing the thread until it's ready. Well, if you're using one thread and want to handle multiple tasks like game loop, then you want right. And this is actually the behavior that we want. We want it to be blocking in this case. So we have to reassign the con to the new connection. That's pretty straightforward there. We can get rid of that one. And so we have con adder. Socket accept. So is that going to be the same thing? No, it's different when you do connect. When we do n.connect, it returns the it returns a socket object. So this doesn't return except con adder. What does it return here? What does it run? Returns a tuple of two values: the client socket and then the client address. Server socket accepts. So it's client socket object, new socket object to that client. Use to send receive data with just that client. You can call receive send on this and the client address. Okay, got you. Okay. But socket.con, well, it's not socket.con actually. What is it here? So it is, yeah. Socket.connect returns just socket objects. Socket connect returns none on success. Returns none if successful. It returns none. So it doesn't return. So it doesn't return a socket object. Does not return a new socket object. Everybody's on the existing socket instance. Modifying in place. Oh, whoa. Hold up. Wait a second. Oh, I see. Right. So when we do connect, it doesn't return anything. We just end up returning the socket after. I'm an idiot. Ah, ha, ha. Okay. Okay, I'm dumb. I had that wrong here. Oh, hold up. I had that wrong. Let's fix that. So let's go over here, and this is incorrect. We actually from a quick code review, it seems that con here is the exact same object as n.network socket. Over there, interchangeable. Then we should probably use con instead of an n.network socket. And that's only because, yeah, that's not how this works. So we would just run n connect, and that will. Well, that's a different. It's not socket.connect. That's why it needs to be changed. See this fucking namespace that I chose? It's bad. Having functions with the same name as, like, don't do that, you know? Don't do it. That's why you need to have very specific names for your stuff, because you use generic names, you think you're being clever and simple, and sometimes it just ends up being really confusing. It'll cause you a lot of headache. So we have connect here. This needs to be rename this function to network connect func to differentiate from sockets.connect. Yes. But for now, so if con equals n connect, so this is not gonna be con equals n connect. Well, actually, this would be. Okay. Yes, this would be. But we need to change the name. Let's just go ahead and change the name right now. We're gonna call it network connect function. That's what we'll do. Yeah. So this is gonna be called let's see, connect, and then we'll search for that. Now I'd like to say this would handle. So let's change this one first. So we're going to change this to be network connect function. So network connect function self IP port combo. Let's just give me a change here. And then we call network socket dot connect. There we go. And it will return self.network socket. Alright, that's fine. Alright, so now we're gonna find all the instances where this is called. Like right here. And we're gonna change this to be network connect func. So now this confusion is gone. That was a silly way to have that. This is client n.connect. Okay. Network connect function. There we go. Much better. Okay, that's for connecting to the database. It's different. See, we're clearing things up, guys. It just takes time. Alright, now where exactly was I before I got fucking sidetracked, man? Where the fuck was I? I don't forgot where the fuck I was, dude. I was somewhere. I was in server, right? Yeah. What did we do though? Okay. Okay, we were confused about that. What are returns? Con adder. I swear this one just we do con. And let's see, where was that? Let's see. Okay, that was line 353. 353. So let's go up here. Real quick, it assumes that con here is the exact same object as in network side. Yes, they actually are. I don't have to, like, I already just reviewed that because it literally calls that function. Well, it calls the function from network, which literally returns that object. So use con instead of network side throughout this file if true. Okay, well, we do actually need to, like, that does need to be done. So we'll leave this. We'll take care of that another time. I'm trying to stay on track as much as I can here without getting sidetracked too much. Okay, so back to server, what we were doing, reconnect system, add code to reconnect client using the reconnect socket. So we have con adder, and that's what we were confused about. The accept socket accept returns the tuple, which is the con adder. So that is correctly coded. So that will accept a connection, and then the first thing that they're gonna do is the client is going to connect. Let's see, where's the corresponding connect? The corresponding connect is right here. Okay, so now they reconnect, and then we send them the header, and then we send them the serialized client token. And like, I'm pretty sure we can send this as one line, but I'm gonna leave it just to be safe because I got a lot going on. I want to play safe, and then I can go back and, like, you know, sometimes you're not sure about things, you come back, change it later. Just like play it safe at first. If it's like, unless it's crucial. This is not crucial. This is like combining. It's saving a line. Can't we combine this into one line with send all x plus x? Yeah, I think we can. Alright. So that's what happens. We send the header and the serialized client token, but it's a stream, so like it's not two separate sends. There's literally just a line of bytes, so we don't have to do two separate receives. We can just receive those first 7 bytes or whatever, which is the header. Yeah, anyway. So we need to receive the header first. So we're gonna do receive the client token header sent from CS, and then we need to receive the client token sent from CS. And then we need to, what do we need to do, baby? After we receive the header, we receive the client token, and once we get the client token, well, we need to compare it against the original token, right? Compare client's token against original token, right? And if valid, I guess we need to like send them back a message to say, I guess if they're valid, we just like, we would reconnect or just like continue. Continue game, and then if not, whoa, man, what did I do here? What the f is going on here? Stop that! Stop that! Hey! Whoa, 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 whoa! Stop that shit, man! Bro. Get out of here! Alright. I don't know what we did there. I did shift enter. The shift enter. I promise you, I don't know. damn, I didn't even know you could do that. Okay, because it's from the Python extension. Install the Jupyter extension. We don't actually have. Well, yeah, that's optional. Interactive window. All right, I understand. It's running like. I didn't have any code selected. Okay, valid continue game, but if invalid token, well, then we have to. I mean, that means they're spoofing or something. Send message to client informing them they are spoofing or some shit. Right. Receive 2 messages client ID signed from the direct maps client token via checking. Let's create this dictionary match. Continue. Okay. So we have the client ID. Client token dictionary. Okay, and that makes sense because we have to map it somehow. We can just have a list of tokens, right? Because then we would just have to check every token. That would be silly. So we would use, copy these 2 lines here. So I have ConAdder, reconnect socket, accept. We have receive client token from CS, receive client token. Compare client token against original token. And we would do that through this means here. There we go. So we compare the client token against the original token via checking the client ID, client token dictionary. We have to create that dictionary. Alright. So we have to create this dictionary. And we also have to populate that dictionary at the time that the client token is created initially. Right? I think so. So it's right here. Put that. Create a server-side code. To create the client ID. And then we need to create code to populate. So we need to populates this dict with key equaling client ID, val equaling the client token. Populate this at time of creation of client token. I think that makes sense. Okay. Yes, like that. All right. So now we have receive the client token header for centerpiece. Yeah. So how do we do this exactly? We'll say con dot receive, and we're gonna receive the. Well, don't we receive the first 7 bytes? Yeah. Header string equals con receive decode. Con receive 7 decode. True, true, true. And then we do con receive header amount. So we do like this. Header string equals con receive 7 dot decode. We'll say client token header string equals con receive 7 dot decode. So we're receiving the first 7 bytes and then we're decoding it because that's gonna be it should be able to be decoded from bytes directly into string. So that should work. Now, if it was like a more complex object, that might not work, right? I think. If we try to use decode, on non-string original object, would it work? No, trying to use decode on a non-string origin object will raise an error unless that object is a bytes that was previously encoded. Yeah, so it would raise an error. Gotcha. Okay. Yeah, so we can use decode on that though, because it was a string, right? Well, that's what header creates. I think so. Yeah. Well, it returns a byte object that was a string. So, and we use encode, so obviously decode would work with it. Okay. There we go. So that should take care of that. Receive the client token header. And this is actually the string because it decodes it as well. Okay. So we'll say decodes the bytes back to string. Header. Bytes back to string. Now we have to receive the client. Or, well, that should actually be called just the, what do we call it? The header string. Oh, see, and then we have to do all this, the header amount, and we gotta extract the actual value from it. Yeah, okay, that's fine. And this should be in a string. Oh yeah, we need the con lock, huh? So that code needs to be in a function. I'm just gonna go ahead and say that. 433 to 442. $433 to $442. $735 to $744. $735 to $744. Okay. Gotcha. Yeah, because multiple threads handle this connection. But technically at this point in time, I think that the namespace reference so if a connection, let's see, let's try to figure this out here. Do we need to recreate the lock? Concerning this, would we need to create a new lock object since would reference old con object? Also, does this mean we would need to create I don't think we would need to reassign, like, if anything just referred to con. Yeah, because multi-threads share the same memory. So when we reassign con equal to self reconnect socket accept, at this point in time, it's going, like, this whole process is going to understand that the namespace con refers to this new connection object. So even if another thread accesses con, it's going to do so, well, unless it accesses it through the other namespace, such as other con, which might be the case. And yeah, I think that is what would it do, because we let me see. Subcon 2. And so we also have the con adders that also would need to be reassigned. Yeah, see, because we do other cons. So that would have to be handled. Because it's referring to an old con object. Yes, yes, yes. See how complicated things can be, baby? Do you see? Do you see what I see? The other con, like, other cons send all, baby. Oh, man. Also, does this... well, I'm pretty sure. Also, this means we need to reassign like self dot other con and other objects adders to refer to the new con objects. So this means we need to we need to create a new lock because this is a new connection object, right? Yeah. Well, this is like you need a new lock for the new con. It's the con log, yeah. So, all right, let me take care of this. I'll put this up here. So that's done. This is gonna say it's gonna be to do here. To do 7, 21, 25. Need to reassign self.otherCon. Say self.con, self.otherCon, conlock, self.conlock, self.otherConlock, etc. To refer to the new con object. Yes, yes, yes. Thoroughly review. Because that's very sensitive. That's a lot of affected stuff. Okay, so let me... After we create the exception, we can do that. We'll do that another time. We're going to receive the client token here from CS. We'll add this to our to-do list. Current issues. Shit, man. Reassign various adders objects in server.py. Signs. We'll say, let's do our format here. Create code in, or create, revise code in server by 2. Revise server side code in server by to reassign various adders objects to for new con objects. Yes. Here we go. Need to reassign some. Be careful. Be careful. Thoroughly review. It's always better to go slow and triple count chocula double check, dog. Triple count chocula triple check, dude. Never, ever measure once. Always measure like 3 times. Insane, bro. Even the best, which I am not, by the way, but just even the best fuck up the first time. I feel like I'm actually dying here, guys. About to be time for a sniggity snack, right? Time for some cereal and some more caffeine. Because the juice isn't here, baby. It's just not. Alright. So we received the client token header from CS. Duplicate code that needs to be converted to function. Yes. Alright, so let's review this. We have the header string. Well, this needs to be created by the. That's going to happen after. Let's open these up here. To populate the dictionary. Do this after that. We'll do that after that, dog. Alright. So receive the client token header sent from the CS. There we go. So we have received it. Do we need a conlock here? We probably do. Yeah, we do need the conlock. So this actually that will be taken care of. So we'll just leave it as is. We already have it about the conlock and shit. Okay, so we receive it, the first 7 bytes. That's going to be our header. We're going to release the conlock, but we actually have to acquire it first because it hasn't been acquired. So let's do that. So we need to acquire that shit. Give me that shit, cuz. Acquire the conlock. Header string is going to use 7. And you decode it, so it converts it from bytes to string. Then we would release it since we're not handling the con anymore. Header amount is blank string. We have our num list. We iterate through the header string. If the character is in the num list, then header amount is plus equal to. Couldn't we just say if char is not equal to x? Yeah, couldn't we change that? Could we just say, check if char is not equal to x, since x is only other like objects or character other than nums, than ints? I mean, I think that would be easier. Look at that shit. Look at that stupid shit it's doing. Dumbass shit. Out of here, bro. 745. Okay, so it iterates for the character in header string. If char is in num list, header amount plus equals char else break. There's a better way to do this, right? There's a way easier way to do this. It's fine. It's fine. And then header amount is equal to the int of header amount minus 33. Why do we do minus 33? Although the encoded header object is 34 bytes, according to sys get size of, before it is sent through the server. When it is received here, it is only 7 bytes. I don't understand why, but after some testing, it seems to be working properly. Well, then why do we have to do minus 33 then? Why do we subtract 33 here? Original size is 34, so we end up with 1 byte or something. Yeah, this is just old code. I just don't remember like why. Let's ask Chippy Jip. Chippy Jip's gonna know. Just gonna paste this in. I'm gonna say, why is the final amount minus 33 if we only received 7 bytes? Alright, header string equals count received 7. Parsing digits from header string into header amount is int. You receive 7 bytes from the socket, decode them to get a string like 00034x or 34x. You extract numeric values from the string to build the number. Then you subtract 33 from this number. This is just a number you receive in the header is offset by 33 from the actual length of data to be received. The header contains a length plus an offset. Maybe the sender adds 33 to the length before sending it. So the header number includes some kinds of padding, overhead, or a fix. Subtracting 33 here reverses that and gets the actual length of the upcoming payload. The header is not the full data. It's just small prefixing codes, even if the payload, but it's not payload. No. See, what we do is we get the header. And then we send it. This is the function which sends the header object from the other side of network. Does this explain why the 34 and the minus 33 and the 7 bytes? Your message identifying explains logic behind receiving 7 bytes. Let me break it down clearly. So 34, the actual size in bytes. So the object size string. 34, if the length of the string is less than 7. Length 34 is 2. It's less than 7. Pen 7 minus 2 equals 5. So object size string. So it'd be 34xxx, p34xxx, and then this ends up being 7 bytes long. is the integer value of the leading digits, just 34. This assumes the number of parts from the header. I don't remember, like, I don't think this is right. I was confused at some point. I don't know why the fuck do we do minus 33 there. That doesn't make sense to me, dude. I mean, I've been using this code for a long time, so I'm assuming it works, but I'm just like, why? It says the encoded header object is 34 bytes. According to sysget size before it is sent through the server. When it is received here, it is only 7 bytes. I don't know. I'm gonna have to look into that. I'm just gonna have to look into that. So review, part of the review, this is going to contain that. We'll put this in the review section. We'll say, review the message header format and numbers such as the supposed 34 byte size before sending, but only 7 bytes sent, and the subtraction of 33 bytes on the receiving end to get correct byte objects. Very confused about this. Very confused about how this works. Despite this being old code and quite certain it does actually work properly. Anyway, alright, we'll move on from that. Everything is current safety code, kind of blah 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 blah. Alright, so this is not the section I was working on. We got 751 here. Header amount equals header amount, blah blah blah, minus 33. And we don't know why. We're going to figure that out. Alright, but anyway, finally, so we start off with the header string. We end up with the header amount, okay, which is the integer, and then we have to receive the client token, and that would be done through calling con.receive, and then we would receive the header amount, right? Yes, because that's why we sent the header in the first place. So we say con receive header amount, and that has to be deserialized, right? Yes, because it is a serialized object, so we would have to deserialize the serialized client token sent from CS using pickle dot loads. So this would be actually whoopsie. Let's receive this serialized client token. receive the serialized client token. So this would be serialized client token equals the and we actually use this namespace elsewhere, right? No, we don't. Okay, so we're safe on that. Alright, so the serialized client token equals current receive header remote. Then we deserialize the serialized client token. So now we would do deserialized, or we could just say client token. We'll say received client token. Received client token. So this would be received client token equals pickle.loads. So it loads in bytes object into back to Python object. So it converts the serialized receive client token back into the actual original format. And then we have to compare the received client token against the original client token. Okay. So that would be create the at proper location, not here. So then we would say client ID, well, we just paste this in. At client ID. Oh, well, we have to extract it, right? Yeah, we have to extract it from the payload. So in that case, we would send the fucking client ID with it. Instead of having to extract a client ID. Okay, we're gonna take a break. We're gonna take a break, guys. Let's see. Deserialize client token, server make a load, receive client token, serious receive client token. And I really don't want to do all the code that breaks down the client token. I would rather honestly just be sent the client ID. Yeah, we need to receive so we need to receive the serialized client ID. Fuck, man. Client ID and client token. That's really long name. Who cares? Can't receive header amount. So we're gonna stop here. We're gonna have to modify the code. Motherfucker. Son of a bitch. Damn. Server? Server. Oh man. Dang, bro. It's always more, though. It's always more little shit. It's little on top of little on top of little on top of little. It just it spawns as it is written. It expands. It's recursive. As you write it, it needs to be written more. As you refactor, it needs to be refactored more. It grows as it grows. Whenever you prune it, it grows in the pruning. It is a very much a living, breathing thing, dude. It just gets bigger and bigger, man. All right. Anyway, it's not that big a deal. I didn't think about that. It's very easy to do. Like, this is super easy fix. It's just a bunch of super easy fixes that keep spawning, and I need them to stop. You know. What was that? Oh yeah, I was confused about this. Anytime I'm confused, I gotta be not confused. Being confused in me. I can't continue while confused, you know? Some people can just kind of put the confusion off to the side, but I'm kind of the guy where I'm like, I get confused, I gotta stop, hit the brakes, and figure out why is this how it works. So, if a client received a server created client token that was uses, what the fuck is it? Secure token technique creation with signature and all that with payload. How and a spoofing client got a hold of that token, what would stop the spoofing client from pretending to be that client and sending that token to the server? That is what is confusing. A secure token design must include more than just cryptographic signatures. If a client receives a signed token and an attacker gets a hold of that token, they're going to be reused by the attacker unless additional protections are in place. So what would stop a spoofing client from reusing the token? Nothing, unless you explicitly design your system to prevent that. A valid token with a valid signature is still valid, no matter who presents it. Right. Depends on series replay attacks. To stop a spoofing client from impersonating the real one using a stolen token, you need additional layers. Limit token lifetime. Well, that's dumb. No, that's not. No. Bind token to client metadata. Include client IP, user agent hash, or device ID. This breaks if the real client's IP, right? So one time use nonce. Mark each token with a random nonce or ID. Insert on the server after first use. If the server sees that token ID again, reject it. Yeah, because you'd have to, like... There has to be... I could say, like, okay. Maybe on the server side... Let's just keep going here. I'm thinking. Use client certificates, MTLS, so the client proves it has a private key. Now, even if the client is stolen, the attacker can't use it without the private certification. High security, but harder to manage. So the client certificates, so the client proves it has a private key. Use HTTPS TLS, prevent the token from being stolen in the first place. The unencrypted HTTP is vulnerable to man-in-the-middle attacks. Rotate and reuse issue tokens frequently. I don't really want to do that. I was thinking the client certificate. So we'll add this to things to do. We're going to focus on it another time right here. We're going to add that another time. So we're going to say client side, or we'll say CS client token hacked security fix. Let's see, 29, 25. Concerning, say, consult with ChatGPT to use more security measures to ensure that the received client token on the CS can't be stolen and used to spoof as the client. Perhaps use client-side encrypted signatures or something to resend the token back to SS and reassign the token to the new token. Perhaps use client. This could be done using could maybe use client certificates, MTLS. This is MTLS to accomplish this. Or perhaps have token quickly expire and send new token. Client frequently. That one requires more work though. So with client certificates, MTLS or something, we could have the client sign the token as well, resend the token back, and then the server would use the new token as verification method, which includes CS signature sig as well. Is that something like that? You're exactly. With client certificates, MTLS, you can absolutely have the client sign something, and the server can verify the signature using client's public key. This gives you proof of possession of the private key, meaning only the real client could have created the signed message, even if the token itself was leaked. Stronger automatic authentication. The client presents a certificate during the TLS handshake. The server verifies it's from a trusted CA or your own system. Once a connection is established, you trust the client identity because only they could complete the handshake. So it's a secret fucking handshake, alright? No need to manage separate token signatures. Automatic via TLS libraries, very strong identity check. And then 2 is the token plus client signature. Even flexible and common in lightweight or game scenarios. Server guarantee generates a challenger token. Client signs the challenge using its private key. The client sends back the original token challenge. The client's public key or certificate, the signature. Server verifies that the token is valid. Signature matches using. Okay, yeah, I see exactly what we gotta do, bro. I see exactly what we gotta do here. Server verifies the token is valid. The signature matches using the client's public key. Optionally, you can have the public key is trusted if it's registered before. So example structure is that. Pros, it works over HTTPS or TLS handshake certification needed. If it's customer game-specific protocols, you can bind the token to the client identity cryptographically. Okay, yeah. we're gonna stop there. And anyway, all right. So we're probably gonna go with that option. Blah 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 blah. See chat GPT thread from 7/29/25 for reference. Yes. Okay. Okie hokey, we did it. So we gotta refactor that code just a little bit, dog, and cause I don't wanna extract the client token because there's a lot going on with it, and like sending the client ID is like we'll figure it out, bro. We'll figure it out, dude. Alright. You get a little scattered, you know, and thinking about all these different things, and there's so many variables, but we're gonna leave that be for now. So we did 30. That's actually 36 minutes, so it's an hour and a half. Alright, so from 11:12 to, we'll just say basically 12:20, we continued working on code which will reconnect the client, but we mainly worked in server. Well, server pi and client pi. We did a little bit of. Did we actually modify any code in client? I think we did just a little bit, so we'll add it. Specifically, we did things. What did we do? Well, let's see here. This would be from 11, 12, 20. Begin invitation to go to server pi, which receives the client token from CS for authentication. Yeah, that's it. Begin invitation code and server which receives the client token from CS for authentication. So it receives the client token from the client side. Yep, that's it. So we gotta do a little refactor that's like 15 minutes. We gotta create that, that's 15, 15, 30, 45. That's another 15, so that's an hour. It's another 15, so an hour 15 as a result. Well, that's a duplicate. Client ID, client token dictionary. Yeah, I literally have that. Yes. What is this? Alright, yeah, so we're looking at 15, 30, 45, 60, 75. Yeah, so you're looking and then review. So we'll say another hour. So 2 hours and 15 minutes. Something like that. Some shit. 15, 30, 45, 60. An hour and 15. And then another hour. So you're looking at 2 hours 15 before we actually run tests. Yeah. Getting closer. Sort of. It always runs away as we get closer, but you know. We are doing something, right? Alright guys, I'm gonna go. I got I gotta take care of. Important. Gonna eat a little snack and then go to the gym maybe. I don't know. Might skip the gym today. I'm gonna try to do another session though when we get back once we're done doing what we gotta do.